Everyone, as you know that I have started a new lecture series which is based on previous year questions of thermodynamics, and I will deal the question of GATE, engineering services and civil services. So this will be very helpful for mechanical engineering students. Okay, so I have already completed one lecture, that is a question for GATE. Okay, question from GATE. Now today we are going to see the question of engineering services, and the topic will be basic concept. Okay, this is about myself. Let's start engineering services question. Okay, so the first question is, which of the following are intensive properties? Okay, kinetic energy, specific enthalpy, pressure, entropy. Okay, so its answer is actually C, specific enthalpy and pressure. These are called intensive property. Okay, so answer is B. You know that. Okay, those property who does not depend on mass, that is called intensive property. Okay, the kinetic energy depends on mass, entropy also depends on mass, so that's why these two are not intensive property. Specific enthalpy and pressure, these two does not depend on mass, so that's why it is called, these two is called intensive property. Okay. Next question, consider the following properties: temperature, viscosity, specific entropy, thermal conductivity. Okay, so which of the following properties of system are intensive? Okay, so they are asking for intensive property. So this is actually, D, all are the intensive property: temperature, viscosity, entropy, thermal conductivity, all are intensive property. Okay, temperature, viscosity, specific entropy, thermal conductivity, all are intensive property. So intensive property whose value is independent of size or extent, that is mass of the system. Okay, specific property is nothing but it is specific property, it's like per unit mass. Okay, if you divide with any property, if you divide with mass, so that convert into a specific property. It is a special case of intensive property. Its value of an extensive property per unit mass of system, lower later as a symbol. Okay, specific volume, specific density. Okay, so suppose any extensive property is there, so if you divide with mass, then it will convert into intensive property. Okay, so it denotes on lowercase letter of as a symbol. Okay, so if you are a mechanical engineering student, you can easily understand. Okay, this thing is like very simple thing and very basic from the thermodynamics. I don't think is much explanation is required for this question. Okay, next question. Consider the following: kinetic energy, entropy, thermal conductivity, pressure. Okay, so intensive property. Again, this question is intensive property. I think this is the same question since it has been repeated twice, so that's why this question is coming again. So this is actually thermal conductivity and pressure. These two are intensive property. I think, yeah, there was a specific was there, no problem. Okay, so the kinetic energy half mv square depends on mass, entropy kilojoule per Kelvin depends on mass. Entropy is extensive property, but specific entropy is an intensive property, because if you divide with mass, then it will convert into intensive property. Next question, which of the following is the extensive property of thermodynamic system? Okay, volume, pressure, temperature, density. I think we have seen many questions, so I think solve this question is volume. Okay, so extensive property depends on mass, thus the volume is extensive property. Okay, so the answer is A. Next question, consider the following properties: entropy, viscosity, temperature, specific heat at constant volume. So they are asking for extensive property. Okay, so extensive properties are those properties which depends on mass. So you have to see that, so there is only entropy which depends on mass. So the answer will be A. Rest, viscosity depends on mass, temperature is intensive property. Okay, viscosity is also intensive property, does not depend on mass. Constant specific heat at constant volume is also intensive property, it does not depend on mass. So okay, the answer is A. Extensive property whose value depends on size or extent, that is mass of the system, uppercase letter of the symbol, that is volume, mass, VM. If mass is increased, the value of extensive properties increases. नेक्स्ट क्वेश्चन, कंसीडर द फॉलोइंग. ओके, देखिए इंजीनियरिंग सर्विसेज वाले क्वेश्चन करने में यही फायदा होता है कि एक ही टॉपिक से ना काफ़ी क्वेश्चन आए हुए होते हैं, तो वो चीज़ें ना काफ़ी बार रिपीट होती है, यू कैन रिमेंबर वेरी इजली. ओके, सो इफ यू आर सॉल्विंग इंजीनियरिंग क्वेश्चन, इंजीनियरिंग सर्विसेज क्वेश्चन टॉपिक वाइज. ओके, सो हियर टेम्परेचर, viscosity, internal energy and entropy. So they are asking for extensive property. So what is extensive property? Which depends on mass. Okay, so let's see that here. Okay, see, viscosity and internal energy, no, sorry, is not internal energy, is entropy. These two are extensive property. One second. Temperature does not depend on mass, is a intensive property. Viscosity does not depend on mass, is a intensive property. Entropy depends on mass. Yeah, this depends on mass. And internal energy, okay, internal energy and entropy depends on mass. So that's why these third and fourth are extensive property. Okay, this temperature and viscosity, it does not depend on mass. Okay, so the properties like temperature, viscosity, which independent of mass of the system, called intensive property. Okay. Next question, this is thermodynamic system and control volume. So let's read that assertion reason. A thermodynamic system may be considered as a quantity of working substance with which interaction of heat and work are studied. Okay. Energy in the form of work and heat are mutually convertible. Okay, see, the first statement is actually wrong. A thermodynamic system may be considered as quantity of working substance with which interaction of heat and work are studied. No, this is wrong. This is completely wrong. Okay? Energy in the form of work and heat is mutually convertible. Yes, this is correct. Okay, so the answer is D. You can read this explanation. Next question, control volume is an isolated system, a closed system, but heat and work can cross the boundary. A specific amount of mass in space, a fixed region in space where mass and heat can cross the boundary of that region. So it is actually D, of a fixed region in space where mass, heat and work can cross the boundary of that region. Okay, so that is nothing but a control volume. Answer is D. Next question, open and closed system. A closed thermodynamic system is one which there is no energy or mass transfer across the boundary. There is no mass transfer, but energy transfer exists. There is no energy transfer, but mass transfer exists. Both energy and mass transfer take place across the boundary, but mass transfer is controlled by wall. So this is actually B. There is no mass transfer, but energy transfer exists. Okay, this is actually definition of closed system. Okay, no mass transfer, but energy transfer exists. Okay, in a closed thermodynamic system, there is no mass transfer, but energy transfer exists. Next question, isothermal compression of air is Stirling engine is an example of open system, steady flow adiabatic system, closed system with a movable boundary, closed system with fixed boundary. So this is actually C, closed system with a movable boundary. Okay, so it's a closed system with a movable boundary. Okay, so this was the end of engineering services question. This is actually, I think, one part. There will be many parts. because I don't want to make very lengthy video for this question. My target is to 10 minute 10 question or 12 question. Okay, that's it. Thank you for watching. Bye bye.